where massive, heavy coils of stainless steel arrive from mills. These are not just any steel coils. They are rolled with precision to meet incredibly strict standards. The most common choice for the stove body is high-quality stainless steel, often grade 304.
A grade like 8 and 10 stainless steel tells you it is made of 80% chromium content.
Chromium is the secret sauce for corrosion resistance, creating an invisible layer that protects from rust.
It protects against all the spills and cleaning that happen in a kitchen, ensuring lasting durability.
The nickel adds durability and gives it that bright, lustrous shine that we all expect from appliances.
For parts needing extreme shapes, factories use a specialized type, like deep draw quality stainless steel.
Before a single cut is made, a critical quality check happens as a technician snips samples. They take the sample to the on-site lab where they double-check the supplier purity certificates immediately. They measure the steel thickness with a micrometer to make sure it is uniform and precise.
This consistency is vital because any little difference could cause big problems in massive presses later.
They also run tests to ensure the percentages of chromium and nickel are exactly right today.
This tough inspection is the first, and maybe one of the most important, steps in building.
Guarantees the stove foundation is strong, tough, and ready to handle the heat of kitchens.
Only after a coil is certified does it move onto the factory floor for transformation. Validated coil of stainless steel, which can weigh several tons, is lifted by an overhead crane. With a low hum, the machine starts turning, feeding the tightly wound steel into heavy rollers. This is the flattening process, designed to remove the coil memory and create a perfectly flat sheet. The sheet glides forward onto a CNC, or computer numerical control, shearing machine for precise cutting. A worker just has to enter the right dimensions, and the machine automatically adjusts for them.
The steel sheet is pushed into place, and with a deafening crash, a massive blade descends.
It shears the steel with incredible force and precision, separating the continuous strip into manageable sheets.
This first stage cuts the giant sheet into large rectangles, the main pieces for the body. These rectangles will soon become the stove body, side panels, and the top surface we use. But a stove needs more than just big rectangles. It requires dozens of smaller, intricate parts. Internal brackets, support beams, and burner mounts are all needed to hold the structure together firmly. These smaller pieces are moved to other cutting stations, where we will see a few technologies. For parts they make thousands of, a stamping press with a custom cutting die is used. With each thunderous blow, the press punches out a perfectly shaped component, exactly like a cookie cutter.
For more complex shapes, factories often turn to laser cutters to achieve the difficult designs required.
In a shower of brilliant white sparks, a high-powered laser, guided by a computer, traces paths.
The laser's intense heat vaporizes the metal, leaving behind a perfectly clean edge without touching it.
This method allows for incredible precision with very little waste, maximizing the efficiency of the material. After all that cutting, the edges of the steel are incredibly sharp and can have burrs. So the next step is deburring, where parts pass through a machine with rotating abrasive brushes.
Or they are finished by hand by workers with grinding tools to ensure safety for everyone.
They carefully smooth every single edge, making them safe to handle and ensuring a perfect fit.
Once deburred, the flat pieces are sorted, stacked, and ready to be given their three-dimensional form.
This is where the flat sheets of steel really start to look like a finished stove.
The rectangular blank that will become the top surface is brought to the titan of the floor.
This hydraulic deep drawing press is a behemoth, capable of exerting hundreds of tons of force.
The process starts with prep, as the steel blank gets coated with a special lubricant mist.
This step is absolutely critical, because without it, the immense force of the press creates damage. Without it, the steel would tear, wrinkle, or even weld itself to the tool under pressure. An operator places the lubricated blank onto the lower half of the die, a hardened mold.
With the press of a button, a safety cage slides shut and the upper punch descends.
The punch begins its slow, powerful descent, making contact with the steel to start the transformation.
The edges of the blank are held down firmly to prevent the material from wrinkling up.
You hear a low, intense groan as the pressure forces the steel to stretch and flow.
It transforms the flat sheet into a three-dimensional shape without a single cut being made today. The operator pulls out the newly formed part, which is now unmistakably the top of a stove.
It comes complete with the recessed areas for the burners, formed perfectly by the cold working process.
If the steel gets too hard from being worked, it has to be heated in a furnace. This relieves the stress before it can be drawn again, a process known as work hardening. Once the main body is formed, it moves to a series of smaller, faster mechanical presses. Here, a punching press pierces the precise holes for the burner assemblies and the control knobs. Other presses are busy forming the side panels, the back plate, and all the small internal brackets. Each part is formed with immense force and precision, ensuring every component is a perfect copy.
Now the factory shifts from making individual parts to bringing them all together on the line.
The process moves to the assembly line, where the stove really starts to take its final shape. The deep-drawn top, the stamped side panels, and the internal frame pieces all meet right here.
The main way to join the big structural parts is welding, often using a mix of automation.
A spot welder uses two copper electrodes to clamp the steel sheets together and passes current. Steel resistance creates intense heat, melting the metal at that spot and fusing panels together.
This is repeated every few inches, creating a bond that is as strong as a rivet.
For corners and joints that need a continuous, seamless connection, a skilled worker steps in now.
Wearing a protective helmet, they use a TIG welder to lay down a perfect bead here. A shower of golden sparks erupts as the electric arc melts the steel, joining the pieces.
This manual touch requires incredible skill to make sure the weld is strong and also clean.
The result is a seamless joint that looks good and holds the structure together for years.
These brackets will support the burners and gas lines, and the loud pop is a rhythm.
They then attach the four legs, which are carefully welded or bolted onto the bottom frame.
This ensures the stove will stand perfectly level,
providing a stable base for all your cooking.
Throughout this stage, quality checks are constant. After welding, an inspector checks every seam for defects.
Jigs and fixtures hold parts in perfect alignment as they are joined to prevent any warping.
An inspector might even place a completed frame on a flat granite slab to check flatness.
They check for any rocking or twisting, ensuring the stove is not just a collection of parts.
It is now a tough, integrated unit built to last, ready for the heart of the system. With the stainless steel body now a solid structure, it is time to install the functional core. The journey starts with the burners themselves, usually made from cast brass or heavy-duty cast iron.
These materials can handle direct, constant flame and are created by pouring molten metal into molds.
They form the burner base and the removable cap, which are then moved to a drilling station.
At the drilling station, tiny, precisely angled holes, called ports, are drilled around the burner edge. The size and angle of these ports are critical for creating a stable and efficient flame.
Back on the main line, a worker installs the venturi tube, a funnel-shaped essential part. It is designed to suck in the right amount of air and mix it with gas.
This air-fuel mixture from the gas jet is what gives you a clean, complete burn every time.
The burner assembly is lowered into the openings on the stovetop and secured from below.
Now the gas plumbing begins as workers route pre-bent brass or aluminum pipes inside the chassis. The main pipe connects to the gas inlet, which then leads to a distribution manifold tube.
This manifold distributes the fuel, branching off to reach each individual burner across the stovetop.
At each branch, a gas valve is installed, and this is the part the control knob turns.
Getting a perfect seal is everything, so workers use a special gas-rated sealant tape on threads.
They apply it to every connection and tighten them to a specific torque to ensure safety. This ensures an absolutely leak-proof fit, preventing any dangerous gas escapes inside the kitchen environment.
Finally, the control knobs are fitted onto the stems of the gas valves, completing the interface.
If the stove has an automatic ignition, the electronic spark module is installed inside the body now. Wires are run to an electrode next to each burner, carefully clipped to avoid hot spots.
When you push and turn the knob, this system creates that sharp, clicking spark that lights.
This entire section is done with methodical care, since safety and performance depend entirely on it.
The stove is now functionally complete, but it does not have that showroom shine just yet.
The heavy assembly process has likely left the surface with minor scuffs and fingerprints all over.
This next stage is all about making it look beautiful as it moves to the finishing department.
Here, skilled workers get to work, starting with a coarser abrasive compound on a buffing wheel.
They guide the wheel across all the steel surfaces, removing small imperfections and weld marks efficiently.
This first pass creates a uniform, satin texture, preparing the metal for the high-gloss shine.
Then, they switch to a much finer compound and a softer buffing wheel for the detail.
With a delicate touch, they go over the entire surface again, bringing out a deep reflection. This is where the steel gets that deep, reflective shine that catches the eye in showrooms.
For a brushed finish, the steel is passed under an abrasive belt that moves in one direction.
This creates a pattern of fine, parallel lines that are great at hiding fingerprints in use.
After polishing, the stove is meticulously cleaned with a soft cloth and a special solvent solution.
They remove any dust and fingerprints, ensuring the surface is perfectly sterile before the next step.
As a final protective step, a thin, blue-tinted plastic film is applied to all major surfaces.
This film acts like a protective skin, guarding the pristine finish during shipping and handling transport. It is the very last thing you will peel off at home, revealing the perfect surface.
The stove now looks exactly as it will in a store, ready for its most important test.
Before any stove gets packaged, it has to pass a series of tough tests for safety. The assembled stove is moved to a dedicated QC bay, manned by the most experienced technicians.
The first and most critical test is for gas leaks, connecting the stove to a line. With gas flowing but knobs off, they brush a soapy water solution onto every single joint. If you see bubbles, you have a leak, and it is an immediate fail for safety.
Some factories also use sensitive electronic sniffers that will sound an alarm if they detect gas.
Any stove that fails this test goes straight back to the assembly line to be fixed.
There is zero tolerance for leaks, ensuring the appliance is completely safe for home usage anywhere.
Once the stove is confirmed to be gas tight, performance testing begins by igniting one single burner.
They check the flame. Does it light smoothly and travel around the entire ring instantly? Is the flame a steady, vibrant blue? This indicates a clean and efficient burn of fuel.
A large, yellow, sooty flame means incomplete combustion, a problem that has to be fixed immediately.
They may adjust the air mixture to ensure the ratio is perfect for that blue flame.
They also check the flame height at both the highest and lowest settings for cooking control.
The technician also performs a combustion analysis, placing a sensor hood over the flame to measure. They measure levels of carbon monoxide, as strict regulations dictate the maximum allowable levels for safety. They also run a temperature test, placing probes on the stove body and the control knobs.
This makes sure they do not get dangerously hot while the burners are running at max. This entire rigorous sequence is repeated for every single burner on the stove, without any exceptions.
Finally, they do one last visual inspection, looking for any cosmetic flaws or loose components. Only when a stove has passed every single check does it get its final approval sticker. The stove, having passed every single test, has completed its long journey through the factory floor.
It is now that gleaming, perfect appliance we saw at the very beginning of our tour.
The final step is packaging, as the stove is placed into a custom styrofoam cradle base.
Pack the cast iron pan supports and burner caps, securing them so they do not move.
The instruction manual is added, ensuring the user knows exactly how to operate their new appliance.
A sturdy cardboard box is lowered over the unit, protecting it from the outside world completely.
The box is sealed tight, labeled with the model number, and stacked onto a wooden pallet.
It is ready for its journey to a warehouse, a showroom, and finally, into your home.
From a massive coil of raw steel to the finished heart of a kitchen, the process
The entire process is a fascinating blend of raw industrial power and delicate human skill combined.
It is the thunder of the presses and the fiery dance of welding torches working together.
It is the precision of robots, all guided and perfected by the watchful eyes of workers.
It is this combination that transforms simple raw materials into an object of daily use and reliability.
If you enjoyed seeing how a modern gas stove is made, be sure to subscribe now.
Subscribe for more factory tours and behind-the-scenes looks at how things are made every week. Hit that notification bell so you never miss an update on our latest industrial deep dives. And let us know in the comments, what everyday item do you want to see next?
Thanks for watching this journey from raw steel to the blue flame of your kitchen stove. Let us take a moment to appreciate the sheer scale of the raw material storage area.
Thousands of tons of potential appliances sit here, waiting for their turn in the production line.
Inventory tracking is digital and precise, ensuring the oldest stock is always used first for quality.
Modern factories also use automated guided vehicles to move parts between stations without human intervention. Safety sensors allow these robots to work alongside humans, pausing instantly if someone steps in front. Preventive maintenance is key. Crews work tirelessly to keep these massive machines running at peak performance.
Lubrication of the machinery itself is just as important as lubricating the steel during the process.
Nothing goes to waste here. The metal scraps from cutting are collected and sent for recycling.
This scrap will be melted down and eventually return as new coils, closing the sustainability loop.
Upstairs, engineers are constantly refining designs to improve efficiency, safety, and the aesthetics of stoves. They simulate airflow and heat distribution digitally before a single physical prototype is ever built. Prototypes undergo torture testing, running for weeks on end to simulate years of heavy usage. Each day, the factory comes alive, a symphony of man and machine working in harmony. The dedication of the workforce is the true engine behind the production of these appliances.
Their skill and attention to detail ensure that every stove is safe for your family.
As we look at the sea of finished products, we see the result of industrial mastery. The brand badge is placed on the front, a seal of quality and a promise kept. When it finally arrives in your home, it is ready to serve for decades to come.
From morning coffee to holiday feasts, this machine is the silent partner in your culinary life.
Simple, reliable, and built with precision, the gas stove remains a staple of modern living. The technology may advance, but the fundamental need for fire and heat remains exactly the same. That perfect blue flame is the ultimate goal of every step we have witnessed here today. As the sun sets on the factory, the production line slows, ready to start again tomorrow.
It is a cycle of creation that powers kitchens around the world, one stove at a time.
We hope this deep dive gave us a new appreciation for the engineering in your kitchen.
It takes thousands of people and machines to make something so simple, yet so incredibly vital.
Check out our other videos to see how refrigerators, microwaves, and other kitchen essentials are made.
Do not forget to subscribe and share this video with anyone who loves engineering and manufacturing.
Follow us on social media for daily updates and short clips from our factory visits worldwide. Until next time, keep exploring the world of how things are made. This is signing off.
It sits proudly at the very center of countless kitchens, an essential appliance we rely on daily. Gleaming under bright lights, this stainless steel gas stove is a perfect blend of form and function.
It is always ready to bring dinner to life. But have you ever wondered how it arrived?
The whole journey starts not in a kitchen, but deep in the heart of a bustling factory. It begins as a simple, unassuming sheet of industrial steel awaiting a flash of sparks and power. That raw sheet is cut, pressed, and forged in a rapid transformation showing incredible force and precision. It takes you from a flat piece of metal to the controlled blue flame of a burner.
Today, we are going inside the factory to see the complete manufacturing process of a modern